Hello everyone and welcome back. Yeah, today's going to be a nice quick day. We are finishing our Unit 5 guided notes. We are going to start with that challenge problem that I left off from last time. I want to see how well you did. I did get some responses via email, and this is a tricky one. This one's a little bit intense, and I think once you see it, you're going to be like, are you for real? So I'm going to show you. We'll go through the challenge problem. And then we just have a handful of miscellaneous problems referring to systems of equations. So we'll know that they are systems of equations definitively, but we won't need a distance chart or an interest chart or a mixture graphic organizer, okay? We won't need any of those things. So yes, you'll see, you will see, Kayla, that is definitely true. Let's take a look at our challenge problem, and I apologize, you're going to be so upset. Sorry. All right. The label on a 12-ounce can of frozen concentrate Hawaiian punch indicates that when the can of concentrate is mixed with 3 cans or 36 ounces of cold water, the resulting mixture is 10% juice. Find the percent of pure juice in the concentrate. So that's actually really important. So first off, we know that we're talking about the ounces of each of these types of ingredients. So I'm going to label the bottom row ounces. I'll move that over so you can see. And then notice we want the percent of juice. So that's going to be our top row, percent. And we need to write correctly. I can write, I swear. That says percent juice. I swear that says percent juice. So we are mixing that frozen concentrate. So I'm going to write frozen concentrate. And we're mixing that with water. Don't you remember doing that? I did that as a kid. I had that frozen concentrate in a can, and you just kind of like rip that little edge off. You rip the edge off and you pop off that like little metal top. And it was just like this super sweet, sugary, like if you taste it, like, ooh, that's so sweet. And then you just dumped it into this big old gallon thing or whatever, this pitcher, and you filled it with water up until it tasted good, right? But you needed the water. You needed to dilute that because otherwise it was, yeah, exactly. Okay, so somebody else remembers. Thank you, Kayla. I used to love those as a kid. That's what we're doing here with this problem. So we're making a juice so we can actually drink. So let's call this, we'll just call it our mixture. Okay, cool. Having our boxes labeled is going to help us. So we know that the frozen concentrate is 12 ounces. Okay, that's the first thing. We know that we're going to mix it with 3 cans. They say 3 cans because remember, as kids, we also filled that can that we dumped the concentrate out of. We dumped that concentrate and then we filled that can and we kept pouring water until we filled it up enough. So we need 36 ounces of cold water. That's actually really important. And then notice the resulting mixture is 10% juice. So we know the percentage of juice in our mixture is 10%, so we're going to write 0.10. That's all the information that we were actually given from this problem. But guess what? That's just enough. Notice, if we have 12 ounces of that sweet, sweet, sweet concentrate, and then we dilute it with 36 ounces of water, then in that pitcher, we have 12 plus 36, which is 48 ounces, right? That's in our pitcher. The next thing we have to consider is we want to find out the percentage of juice in that frozen concentrate. So it's kind of like saying, how sweet is this juice? So we can write F for frozen concentrate. And then notice here, we also have another space for water. This is not another variable. How much juice is in water? When you open your faucet and you put a cup and you put it underneath and you let the water go in the cup and you drink it, is it juice? Exactly. There's 0 juice. So we're going to write 0 in our chart. 0% of juice in water. If you have juice coming out of your water faucet, I'm coming over and I'm grabbing a cup because I've never seen that before. Okay? So 0 is what we want to place here. All right, we are now ready to write our equations. Consider that our first equation was amount of the first one plus amount of the second one equals amount of the mixture, but we already did that. 12 ounces plus 36 ounces is 48 ounces, so that's taken care of. The next equation deals with value. Value is concentration times amount. So F times 12 is 12F plus 0 times 36 is 0 equals 0.10 times 48 is 4.8. Next, we have 12F is equal to 4.8. We divide both sides by 12. So let's take our calculators and we're going to punch in 4.8 divided by 12, and that gives us 0.4. 0.4. Now remember, we're trying to find the percentage of juice in the frozen concentrate. So when we have 0.4 as our answer, that means that the concentrate is 40% juice. And that is the answer to your problem. So the concentrate is 40% juice. That's the one thing that trips everybody up. It's this right here. There's no juice in that water. Trust me. All right, excellent. I told you that one would be like, what the hell? That's all it was? Jesus. Okay. So we are now ready to move to our miscellaneous problems. I think you're going to like these quite a bit. We're going to be able to run through these actually pretty quickly. A vendor sells hot dogs and bags of potato chips. A customer buys 2 hot dogs and 3 bags of potato chips for $6.25. Another customer buys 5 hot dogs and 3 bags of potato chips for $12.25. Find the cost of each item. Let's start off by saying that H is the cost of a hot dog, and let's call B the cost of a bag of chips. Okay, so those are going to be our variables. We'll use that. It's going to be nice and easy. Notice our customer buys 2 hot dogs and 3 bags of chips. So 2 hot dogs and 3 bags of chips for $6.25. Another customer buys 5 hot dogs and 3 bags of chips for $12.25. The great thing about these problems is you're literally just writing your equations word for word. You're doing a word for word interpretation, and then all we have to do is solve the system. This becomes a piece of cake. So we're back to, do you want to use elimination? Do you want to use substitution? I recommend elimination. Okay, do not use substitution for these. So by doing elimination, we could choose to eliminate either H or B. I don't know about you, but I'm looking to eliminate B. Notice we have a positive 3B and a positive 3B. So if we want to eliminate B, we want one to be negative 3B and the other to be positive 3B. So I'm going to make the top equation a negative 3B, and I do that by multiplying by negative 1. Okay, so I'm going to distribute. That gives me negative 2H minus 3B is equal to negative 6.25. We're going to write the second equation directly underneath it. 5H plus 3B is equal to 12.25. And now let's just take a look and combine in column form. Negative 2H and a positive 5H, well, that leaves us with 3H. Notice that these two cancel out, which is exactly what we wanted. We wanted to eliminate the B term. And then we have a negative 6.25 plus 12.25. Well, when you combine these two, it gives you a 6. You can write 6.00 if you'd like. We divide both sides by 3, and we find that H is equal to 2. Recall that H is the cost of a hot dog. We just found that each hot dog costs $2. I'm almost done. I also need to find the cost of a bag of chips. So what I'm going to do is I'm going to rewrite 2H plus 3B is equal to 6.25. Again, you can plug into either one. That's totally up to you. We know that H is 2 So I'm going to plug 2 in here, and then I'm just going to solve. I'm going to go through the motions that we've seen so many times already. I'm thinking that you're sitting there, you're doing this work, and you're like, yes, this is great. I know exactly what I'm doing because I've done this so many times before. We divide both sides by 3. We get 2.25 divided by 3, which gives us, sorry, that looks so weird. Let's fix that. That gives us b is equal to 0.75. Again, remember, we're talking about the cost of the item. So let's write our answer. Hot dogs are $2 a piece, and bags of chips, bags of potato chips, are 75 cents a piece. So they're those little bags. One time I ordered a 25-cent bag of Doritos, and I got one perfect chip in there. It was both disappointing and amazing all at the same time. All right, try number 19, but let's define the variables together. So a vendor sells beef jerky and bags of popcorn. A customer buys 4 bags of beef jerky and 4 bags of popcorn for $13. Another customer buys 3 bags of beef jerky and 2 bags of popcorn for $9. So we want to find the cost of each item. Let's call B the cost of beef jerky. That way we're all using the same unknowns. And let's use P for the cost of popcorn. Okay, and that's pretty much all you need. So now that we have our variables B and P, go ahead and solve this. I'm just going to give you 3 minutes starting now. All right, let's take a look. So we have 4 bags of beef jerky. So we have 4 bags of beef jerky and 4 bags of popcorn is equal to $13. And then we're told another customer has 3 bags of beef jerky. Excellent, Ryan. And 2 bags of popcorn for $9. Okay, so I could eliminate B if I wanted to again, but actually I'm looking at the P's here. I have a 4P and a 2P, and I actually want to eliminate my P's. So if you look at the 4 and the 2, remember we're looking for a common multiple. So a common multiple of 4 and 2 is actually 4. So that means if I have 4P, I want the other one to be a negative 4P. And that's how they're going to be opposites, right? Notice this one's already a positive 4P. So if I want to make this a negative 4P, that means I have to multiply the entire second equation by a negative 2. Yeah, sweet. Perfect, Kayla. So now I'm going to rewrite the first equation. 4B plus 4P is equal to 13. And then I'm going to distribute that negative 2, so it gives me negative 6B, negative 4P is equal to negative 18. So let's combine these two. And as always, remember that you're distributing to each of those terms, not just half of the equation. 4B minus 6B is negative 2B. Our 4P's are going to cancel, which is exactly what we wanted. We have 13 take away 18, which is negative 5. If I divide both sides by negative 2, I find that B is equal to 2.5. Or, think about this. This refers to the cost of beef jerky. So if we put a dollar symbol in front, we know this is going to be 2.50. So $2.50. We also have to find the cost of popcorn. So again, I can write it in either equation. I'm going to write in the second one this time. So 3B plus 2P is equal to 9. We know that B is 250. So I'm going to put that right here. So we have 3 times 250 plus 2P is equal to 9. So we're just going to go through those motions. And we multiply, we subtract the 750 from both sides. This is all the stuff that you're used to, and you can move right through, no problem. Those cancel. You're left with 2P is equal to, and then 9 minus 750, well, that's 1.5 or 1.50. And then you divide by 2, and you find that P is 0.75. So let's write down that beef jerky is $2.50, right, per bag. And the bags of popcorn are 75 cents. And we're done. So excellent work, Noelia and Ryan, on finding those solutions. Let's turn the page and look at one last type of word problem that we're going to see. And we'll see a second one that is just basically practice for that type. Here it is, our last page of Unit 5. Awesome. A movie theater charges $8 for adults and $5 for children. If there were 40 people altogether and the theater collected $272 at the end of the day, how many of them were adults and how many were children? So let's use A for the number of adults. I always like looking at what it is that we're trying to find. So I'm going to start there. And C is the number of children. That's the first thing. Now, here's a part that sometimes trips people up until we have this equation. So I want you to think about this logically. A movie theater charges $8 for each adult. If we think about this logically, if there were 10 adults in a group, they each get charged $8, right? So it's going to be $8 times 10, right? That makes sense. Now, what if those 10 adults brought their kids, right? Not everyone has a kid, so let's say that there are 5 kids and 10 adults. So for every adult out of the 10, they each get charged $8. And out of those 5 kids, they each get charged $5, right? So we can do the math by saying $8 for every adult and $5 for every kid. Now we take it a step further and say, well, we spend $272 altogether, right? So your first equation deals with money. The cost for the adults, the cost for the children, the total cost. That should make sense because this is what we do every single day in the real world. Let's write out our first equation. So $8 for every adult, right? We need the A there because we don't know how many adults. We need $5 for every child, so we need that C there again because we're trying to say $5 for every child and we don't know how many children. But what we do know is that it adds up to $272. No worries, Kevin. So there's our first equation. So let me check off the pieces that we got. $8 for every adult, $5 for every child. They collected $272 total. Okay, we're missing one more piece of information. This says there were 40 people altogether. Well, if there were 40 people altogether, what equals 40? Oh, the number of adults and the number of children. That's your second equation. One thing I want to really urge you to be careful of, and I've seen this before, I've seen students write 8A plus 5C is equal to 40, right? Which doesn't make sense because we're talking about money and then all of a sudden you're saying there's 40 of them. But what about the money? Where'd the money go? Or they'll say A people, A adults, plus C children is equal to $272. That's scary. If you're going to say that the number of adults plus the number of children is $272, then I'm going to say that's pretty messed up that you're only giving them a value of $272. Like they're worth way more. Okay, come on, let's be real. So be careful, make sense of your equations. Don't just write it to write it, okay? Get that out of yourself, get that out of your mind. Be very careful as you do this. So with all this talk, I'm sure you've been moving through solving this system. So let's take a look. I don't know about you, but I'm going to eliminate C. If you eliminated A, that's totally cool. I'm going to eliminate C just because it's smaller. So I'm going to multiply the second equation by a negative 5. That gives me 8a plus 5c is equal to 272. Then I'm going to have negative 5a minus 5c is equal to negative 200. Let's combine these two equations. 8a minus 5a is 3a. Notice those eliminate. 272 minus 200 is 72. And then we divide both sides by 3. So if we have 72 divided by 3, we find that a is 24. And again, as a reminder, a represents the number of adults. So there are 24 adults, but there's a group of 40 people. So if I say that a plus c is equal to 40, but I know that a is 24, well, all I have to do now is solve for c. If I subtract 24 from both sides, I find that c is 16. So adults, there are 24, and children, there are 16. 21 is identical to number 20. So there were 530 people at a play. The admission price was $2 for adults and $1 for children. The admission receipts were $720. How many adults and how many children attended? I'm going to give you a few minutes to solve this. Once you're done, please share with the rest of us. Let's use A for adults and C for children. Great, we have answers coming in through the chat, so I'm just going to start working through this problem. If you're still completing this, just keep going. I will write everything here and you can take a look and make sure that your work lines up with mine. So we know that it was $2 for every adult and $1 for every child. And we know that there were it sold $720 that particular play. We were also told that there were 530 people total, right? So if there are A adults and C children, we know that there were 530 of them. So that is your setup. These are your two equations in your system of equations. I am going to again eliminate C. Since these are both positive 1c, I'm actually going to multiply the second equation by a negative 1 so that they can be opposites. So I have 2a plus 1c is equal to 720. And then I'm going to distribute this to negative 1. So I get negative 1a, negative 1c is equal to negative 530. Combining the two equations, this ends up being really nice because 2a minus 1a is simply a. My c's cancel, and then 720 minus 530 is just 190. So just like that, I found the number of adults who were at this play. Recall that there were 530 people total, and you know that there were 190 adults. So at this point, all we have to do is figure out, okay, well, how many children are there? We're going to subtract 190 from both sides. And we're going to find that C is equal to 340. So let's write our solution. Adults, there are 190 of them. Children, there are 340 of them. In the chat, let me know how that went for you. But besides that, we are officially done with our guided notes. This is fantastic. All right, everyone, that's it. Have a wonderful rest of your day, and I will see you all Monday for either a review session, if that's something you would like, or moving right into Unit 6. So I'll send an email. You check it out. Excellent work today, everyone. I'll see you Monday. Bye.